Hello, seventh grade scientists. I wanted to make this video about how to make a graph so that you can refer to it later, and also because some of you are going to be making your graphs without me in the room. So, when you start with a graph, you should have a piece of graph paper, and I have graph paper for you in my classroom. You should also use a pencil so that you can erase any mistakes you made. Because I'm recording this video, and because I forgot to bring any graph paper home with me, I'm going to be using just regular lined paper, and I'm going to be using a really dark pen so that you can see my lines, but know that this is not the way that you should do it. Now, when you are making a graph of your temperature data, remember we had water, and it was either cold water that you let warm up or hot water that you let cool down. There was some heat transfer happening. You're going to be, we're going to be making a graph of that information. So on a graph, there's two lines or axes. I'm just going to draw those in right now. You have one that's called the x-axis. The x-axis is this horizontal line, and the y-axis is the vertical line. So we have two variables, two things that we measured. We considered the time. Every 5 minutes we took a measurement, and then we have the temperature. We measured what the temperature was every 5 minutes. So which one goes where? Where does time go, and where does temperature go? Well, the x-axis is where you put what is called the independent variable. Now, the independent variable is the one that you had control over. So did you have control when we did this in class? Did you have control over how often you took a measurement, or were you able to control exactly what the temperature was of the water? Well, I hope when you think of it that way, you understand that you had control of how often we took the measurement. The temperature was what the temperature was. So the x-axis, the one that is horizontal, that is where we're going to put our independent variable, time. So I'm going to label that time. And there's different ways to do this, but it's custom. Well, the way I would like us to do it is to write down what that's showing, and then in parentheses put the unit, because time could be measured in days, it could be measured in seconds, and we took measurements every 5 minutes. So in parentheses, I'm going to put the unit we measured in, which was minutes. All right, so I have time in minutes. So that's our x-axis, and depending on the class, we took measurements maybe for 20 minutes or 25 minutes. So you're going to want to spread this out. You're not going to want to have like 0, 5, 10, 15, 20 in that little bit of space. Spread out your measurements to fill your paper. So I'm going to, because I'm going to use the data that I have, which says that we started at 0 and went up to 25 minutes. And so I think if I do every 3 lines as 5 minutes, or maybe every 4 lines as 5 minutes, I'll be able to spread it out and spread my data out and see most of spread it out to cover most of the paper. So 0, 5, 10. So I've got 5 minutes, 1, 2, 3, 10 minutes, 1, 2, 3, 4, 15, 1, 2, 3, 4, 20. There's 25 minutes. So there's my 25 minutes. I just counted in my case, it might be different on yours, but for mine, I could spread it out by using every four lines was 5 minutes. And then, well, by process of elimination, you know that the y-axis is going to be temperature. But now think about that. I hope it makes sense, because, let's see, I'm checking my notes. So I hope it makes sense that time is the dependent variable. The time every 5 minutes you took a measurement, and the temperature is the dependent variable. The temperature of the water depended on how long it had been sitting out. So again, spread out your numbers. And it depends. If you started off with hot water and it cooled down, or if you started off with cold water and it warmed up, you're going to have completely different sets of numbers over here. Now, for my example, I had cold water that warmed up, and it started off at around 5 degrees Celsius and ended up, the highest temperature was close to 25 degrees Celsius. So I'm going to start at, let's see, well, first of all, I'm going to put temperature. And degrees Celsius, I can write this way. So here's my graph. But you can see I wrote temperature degrees Celsius. And I'm going to start at 0, 5, 10, 15, 20, 25. So now I have both of my axes. I have my numbers, and I have them labeled with what I'm measuring and the unit. What it is I'm measuring and the unit. Now, bar graph or line graph? When you were in elementary school, you probably made a lot of bar graphs. Bar graphs are very useful showing data that like starts at 0 and goes up to a certain number. So maybe you counted all the people in your class that had birthdays in October. You start off at 0 and then you counted 1, 2, 3, 4 people had a birthday. And then maybe December, 0, 1, 2 people. Well, temperature doesn't work that way. The temperature of the water didn't start at 0 and it didn't count up to whatever temperature it is. It's a point. The temperature of the water was one number, one point. And so you're not making a bar graph. You're making a line graph. So please don't anyone make a bar graph. Oh, I'll just be crying. Oh, you don't understand graphs if you're making a bar graph. So make sure that you're showing me a line graph. Now, you're going to need to plot your data. And so you're going to remember what you do is I find it easiest to start on the dependent variable, which in our case was time. So let's say my 0-minute measurement. At my 0-minute measurement, it was 3 degrees Celsius. So 0 minutes. Well, what if I don't have a line right at 3? You're going to have to be an estimator. You're going to have to make your best estimation of where it goes. You're not a computer. It's not going to be perfect. But for example, between 0 and 5, 3 is a lot closer to 5 than it is to 0. So my point is not going to be right on the 5, but it's going to be a little bit below. So at the 0 measure, at the 0 time, right as soon as I poured the water, the temperature was about 3 degrees Celsius, and that's pretty close. Not bad. Now, I wouldn't want your point to be down here at the bottom. I wouldn't want your point to be up here. You're going to need to use your understanding, use your knowledge of numbers to figure out where it goes. And then your next data point at 5. Oh, where on earth does that go? Well, it's going to go above the 5. And sometimes I see people draw extra lines in. I think that ends up confusing a lot of people. If you can do it without drawing in extra lines, don't draw in extra lines. Now, in my data, at the 5-minute mark, the temperature had gone up to about 8 degrees Celsius. So again, closer to the 10 than it is to the 5. So I'm going to go above my 5-minute mark, and I'm going to make a dot right where the 8 would be, and so on. So I'm going to make a point, because that's the point, what temperature it was at that moment in time, right there. Here it is. Let me put in my other data. All right. So there's 1. There's 1. There's 1. There's 1. So your data might look something like this. It might look very different than this, depending on what you were measuring. If you had warm water cooling down or cold water warming up. Now I've got a bunch of dots. The next thing to do is to draw the lines. So I'm going to ask you to draw a line from the first point to the second point, from the second point to the third point, from the third point to the fourth point. As you get more experience with graphing data, you are going to learn how to draw some other kinds of lines, some best fit lines. For our purposes, I just want you going dot to dot to dot to dot, but I want you to stop at the last dot. There's something that, again, when you get experience with graphing your data, there's something called extrapolating your data, where an extrapolation is, I see a trend and I think I can continue that trend. I understand what's happening. I'm not going to ask you to extrapolate your data. Please do not extrapolate your data in this case. Then you'll have a nice ruler if you want one. Connect your connect your dots with lines. Here's mine. Again, yours might look similar to this. Yours might look completely different. But there's one thing missing. You know what it is? It's the title of the graph. The title is What tells a stranger who was not in the room with us? They might not be in our class. They might be in Mr. Cole's chemistry class. And if they looked at your graph, they'd understand what you did. Even though they weren't there, this information and your title, between those two things, it tells them exactly what you did. And I'm not going to tell you exactly what to write from your title. It should be like a phrase, maybe even a sentence, but your title must contain these 3 words. Your title must contain the words temperature, time, and water. So those 3 words, temperature, time, and water. I can't wait to see your graphs. What you're going to do is when you're done with your graph, you're going to take a picture where I can see the whole graph, and you're going to submit that as your Canvas. You're going to submit that on Canvas so that I can see it. All right. Thank you very much.